All right, this lesson is going to go over the review for Unit 4 test, review day 1. Okay. So, begin with the matching activity. Match each graph with the number of solutions. This first one intersects once, so that's going to be exactly one solution. The second one, these are parallel lines that never intersect. That's no solution. Parallel lines will never intersect. These intersected once. Okay, down here we have what looks like two lines on top of each other. So the same line, that would be infinitely many solutions. The same line. Also, let's just note for the parallel lines, they have same slope, different y-intercepts. Zoom out a little bit. Okay, and just to go back here, intersect once. These have different slopes. The y-intercepts don't matter. Okay, just some notes. And our last one, these two lines, even though you don't see them intersecting, if you continue them, they will definitely intersect, so that's going to be one solution. They are not parallel. They will intersect. All right, so that was our warm-up. Now, the rest of this review lesson reviews all about the substitution method. So, let's see, there's 9 of these. Okay. Solve by using substitution. So we're given x equals 5. So what we're going to do is take that value of 5 and plug it in for x. So our second equation then can look like 2 times 5 minus 3 instead of 2 times x minus 3. Then we can solve for y. 2 times 5 is 10, and 10 minus 3 is 7. We know that x is 5. And then we found y is 7. So our solution goes x comma y. So in this case, 5 comma 7. All right, let's look at number 2. We're given that the x is negative 6. So let's take that and plug that in for x. So then we'll have y equals negative 1/2 times negative 6 plus 8. So this was our first step. We found x just like that. Now we're finding y. Negative 1/2 times negative 6, so you can use your calculator. Negative 1 ABC2 times negative 6. You're going to get 3. 3 plus 8 is 11. So now we found that y is 11. Every solution is written as x comma y. So in this case, our x is negative 6 and our y is 11. So our solution is negative 6 comma 11. Okay, and I will show you the check for this one. We'll just do that every once in a while. For the check, you're just going to rewrite both equations. Plug in negative 6 for x. Plug in 11 for y. And see if they balance out. Well, negative 6 does equal negative 6. And over here, we would get negative 1/2 times negative 6 is going to be 3. 3 plus 8 is 11, so that one checks out as well. Okay, let's take a look at number 3. They give us x equals negative 3. Okay, so right away we know that x equals negative 3. Let's plug that in for x and solve for y. Be careful here, because when you're plugging in that negative 3 for x, it's minus a negative 3, which is why we should be using parentheses when we substitute in our numbers. 10 minus a negative 3, well, this is the same thing as 10 plus 3, which is 13. We found our x is negative 3 and our y is 13. And that is our solution. We are breezing through these. All right, number 4, we no longer just have a constant that y or x is equaling. Here, y is equaling 2x. So we have to take 2x and plug that in for y, and then we'll solve for x and then go back and solve for y. Okay, so when we plug that in, we get 5x minus 2x equals 12. Okay, so we're going to solve for x here. That's our first step. 5x minus 2x, well, we can combine like terms. That's 3x, right? They both have an x, so just do 5 minus 2 and tag along the x. 3x equals 12. Divide both sides by 3, and we determine that x equals 4. Oops, I don't know why I was putting that there. Okay, so we found x is 4. Now we need to find y. Rewrite the easier of the two equations. The first one has the y by itself already, so let's rewrite that. Let's take this x equals 4 and plug that in for x. So y equals 2 times x, so y equals 2 times 4. Y equals 8. Our solution is 4, 8. I'll show you the check for this one. Rewrite both equations. Plug in 4 for x and 8 for y. Again, plug in 4 for x and 8 for y. 8 equals 8, check. Just use parentheses just to show we're plugging in. 20 minus 8 equals 12. Yes, 12 equals 12, check. Okay, let's look at number 5. Y equals 3x, so take that 3x and plug it in for y. So then we would have 2 times 3x plus 4x equals 60. We're going to solve for x now. 2 times 3x is 6x. Combine like terms. That's 10 x's on the left side. Divide both sides by 10. X is 6. Now let's go back and find y. Well, we know y equals 3x. And if we know 6 is x, y equals 3 times 6, which is 18. Our solution, which goes x comma y, will be 6 comma 18. And number 6, y equals negative 5x. So let's take that negative 5x and plug it in for y. So instead of 2 times y, we can put 2 times negative 5x. Now let's solve for x. 2 times negative 5x is negative 10x. 10x minus 10x, oh boy, when we combine like terms on this side, we're going to get 0x, which is just 0. 0 does not equal 14. That's not true. Never true. So what this means is no solution. Right? If you got like 14 equals 14 or 0 equals 0, it would be infinitely many. But this is no solution. We plugged in our negative 5x for y, and we got 0 equals 14. Okay, we have 3 more to try. Y equals 5x plus 6, y equals 3x plus 14. So this would be one that you could solve graphically if you were given a graph. They're both in y equals mx plus b form. But we don't have graphs on our paper. So let's solve it algebraically using substitution. We're going to take 5x minus 6 and substitute it in for y in the other equation, since it equals y. Then we're given 5x plus 6 equals 3x plus 14. We're basically setting the two equations equal to each other because they both equal y. Now we can solve for x. The x's are on different sides of the equal sign, so we're going to have to minus 3x on both sides. Right? We don't combine like terms if they're on different sides. We have to move the term. So then we'll get 2x plus 6 equals 14. And then we just solve our two-step equation by minusing 6 on both sides and then dividing by 2 on both sides, and we determine that x is 4. Go back to one of the originals and find y. So you can pick whichever one you want. I'm just going to pick the first equation. They both look similar easiness levels. Plug in 4 for x and figure out what y is. 5 times 4 is 20. 20 plus 6 is 26. Our solution is 4, 26. Okay, and let's see, I'll show you the check for this one. So rewrite both equations. This point should be on both of those lines. It should fit in nicely to both of them. So let's see. If we plug in 26 for y and 4 for x, does this check out? Well, 20 plus 6 is 26. Perfect. And what about this one? Plugging in 26 for y and 4 for x. 12 plus 14 is 26. Excellent. All right. 8 and 9 are set up similarly. I'm not going to do the check for those. We'll just solve them. Take this expression and plug it in for y. We're setting the two equations equal to each other. And then we're solving for x. I don't like having negative x's, so I'm going to move all my x's to the right and be left with 5 equals 6x plus 29. Then I'm going to minus 29 on both sides. Let's see, 5 minus 29 is negative 24 equals 6x. Divide both sides by 6. X is negative 4. Now let's find y. Rewrite one of the equations. I'm just going to pick the first one. If you don't like negatives, feel free to pick the second one. We know x is negative 4, so we can plug that in. Negative 2 times negative 4 is positive 8, and 8 plus 5 is 13. So that means our solution is negative 4, comma 13, because we do x, comma y. All right, great. And our last one for today. Let's take negative 2x plus 6. It says that y equals that, so we're going to plug that in for y. Okay, so in this case, they're not being equal to each other, the equations, because they both don't equal y. We know that y equals this one expression, so we can plug that in for y. We're substituting it in. Then we'll rewrite the second equation, all in terms of x. Okay, so I plugged in this expression for y and rewrote everything else. Now we're going to have to distribute this 4. So we have 8x. 4 times negative 2x is negative 8x. 4 times 6 is plus 24. All right, then let's combine like terms. 8x minus 8x, well, that's 0 x's. 0 times anything is just 0, so we don't even have to write that. So we end up with this true statement of 24 equals 24. That's always true. So what that means is that we have infinitely many solutions. Awesome. All right.